Okay, so the question says we should show that the matrix M is invertible where that is the matrix which has been given. So hence find M inverse, the inverse of M. So let's start with the solution. So we have the solution. Okay, so the question says we should show that the matrix is invertible. For a matrix to be invertible, the determinant of M should not be equal to 0. So in other words, the question is asking us to prove that the determinant is not equal to 0. So we should show that the determinant of the matrix M is not equal to 0. So let's do that. So our matrix M, let me write it back. 3 minus 2, 5, 7, 4 minus 8, 5 minus 3 minus 4. So now let's look for the determinant of this matrix. So again, we write our signs: plus, minus, plus, minus, plus, minus, plus, minus, plus. Now we choose a row of our choice. I will choose the first one. So let's start with the first, positive 3. We delete its rows and columns. We delete the row, delete the column. We are left with 4 times minus 4 minus 3 times minus 8. So 4 minus 8 minus 3 minus 4. We take the next number, which is minus 2, but that minus 2, the sign is minus. So it is minus minus 2. We delete its rows and columns. Delete the column, delete the row. We are left with 7 minus 8, 5 minus 4. We take the next number, 5. It's a positive number. We delete its rows, delete its columns, row and column. We are left with 7, 4, 5 minus 3. Okay, so now we simplify it. These are 2 by 2 matrices, so we just look for the determinants. So here we have 4 times minus 4 minus minus 3 times minus 8 plus 2 into 7 times minus 4 minus 5 times minus 8 plus 5 into 7 times minus 3 minus 4 times 5. Okay, so we simplify. So plus 3. So 4 times minus 4 minus 16. Now plus 3 times minus 8 minus 24 plus 2. So 7 times minus 4 minus 28 plus 40. Now plus 5 into minus 21 minus 20. So we simplify it further. Is plus 3 into minus 16 minus 24 is minus 40 plus 2 into minus 28 plus 40, which is 12, plus 5 into minus 21 minus 20, which is minus 41. So we're having big numbers. So we have plus 3, sorry no, let me simplify it at once. So 3 times minus 40 is minus 120, plus 2 times 12 is 24, minus 205. So minus 120 plus 24 is minus 96, minus 205, and this gives us minus 301. So this appears to be our determinant, but this is not equal to 0 as we have proved. So from there we can show that M is invertible. That is, it is not equal to 0. Our determinant is not equal to 0. So that is the first part of the question. Now the second part says we should find the inverse of M. Okay. Now to find the inverse of M, we first write our formula, which is 1 on the determinant of M, which we solved above, times the adjoint of M. So we know the determinant. Now let's find the adjoint of M. To write our matrix, we write it down 4 times. So that is the first time. Write it again. 3 minus 2, 5. 7, 4 minus 8. 5 minus 3 minus 4. 3 minus 2, 5. 7, 4 minus 8. 5 minus 3 minus 4. The last time now. 3 minus 2, 5. 7, 4 minus 8. 5 minus 3 minus 4. Now we eliminate the exterior numbers and we are left with 4 minus 8, 7, 4, minus 3 minus 4, 5 minus 3, minus 2, 5, 3 minus 2, 4 minus 8, 7, 4. Now we group them in 2 by 2 matrices. So we take our first 2 by 2 matrix. So that is 4 times minus 4 minus minus 3 times minus 8. Take the second 2 by 2. So we are just looking for their determinants. Take the second 5 times minus 8 minus 7 times minus 4. We take the next 2 by 2. 7 times minus 3 minus 4 times 5. We go to the next 2 by 2. 5 times minus 3 minus minus 2 times minus 4. We take the next 3 times minus 4 minus 5 times 5. Now we take the next 2 by 2 matrix. So 5 times minus 2 minus 3 times minus 3. Now go to the next. Minus 2 times minus 8 minus 4 times 5. We take the next. 7 times 5 minus 3 times minus 8. We go to the next. 3 times 4 minus 7 times minus 2. So now we simplify them. So 4 times 4, 4 times minus 4, minus 16. Now this is plus 3 times minus 8, which is minus 24. We take the next 5 times minus 8, minus 40 minus 28. We go to the next, minus 21 minus 20. The next, minus 15. Now plus 2 times minus 4 minus 8, minus 12 minus 25, minus 10 plus 9, minus 16, plus 16 minus 20. Now 35 plus 24, 12 plus 14. Now we simplify it again. So this here, 5 times minus 8 minus 40 plus 28. So let us simplify. So minus 16 minus 24, we have minus 40 plus 28, so minus 12, minus 21 minus 20, minus 41, minus 15 minus 8, minus 23, minus 12 minus 25, minus 37, minus 10 plus 9, minus 1, plus 16 minus 20, so minus 4, 35 plus 24, we have 59, and 12 plus 14, 26. Now that is our matrix, that is our cofactor matrix. So this is our cofactor matrix. Now this is not yet the adjoint. The adjoint will be the transpose of that matrix. So the adjoint will be the transpose of the cofactor matrix. So we take the transpose. So our adjoint now will finally be, so the first row becomes the first column, so minus 40 minus 12 minus 41. The second row becomes the second column, minus 23 minus 37 and minus 1. And the third row becomes the third column, minus 4, 59 and 26. So this is the adjoint. Now this is M. The inverse finally is 1 on the determinant. The determinant was minus 301. Now times the adjoint, minus 40 minus 23 minus 4 minus 12 minus 37, 59 minus 41 minus 1 and 26. So that is our inverse of M. We can multiply everything by this, but it is a fraction, so we can just leave it like that. So that is how this question is solved. So thanks for watching this video, and I'll see you guys in the next video.